Oh, hello. I didn't see you there. Today we are going to talk about some groundbreaking research. Today we are going to discuss astrocytes in the medial preoptic area of the hypothalamus in correlation to ejaculation latency. One might ask, what is ejaculation latency? Fret not, I have the answer. Typically, latent ejaculation can be defined as a man's inability to climax during intravaginal intercourse. It is the third leading sexual disorder among men. But in relation to this study, it is defined as the period of time it takes for a male to reach climax, and also accounts for the post-ejaculation interval, which is the time frame after climax, which males are unable to ejaculate again due to an increase of the penile sensory threshold. There's obviously inconsistencies in the amount of sexual behavior when comparing sexually experienced males to sexually inexperienced males. Glutamate, which is in the medial preoptic area of the hypothalamus, is known for creating some of this variability. The medial preoptic area has the task of controlling the sexual behavior of males because, in a typical sexual encounter, glutamate levels will rise in the medial preoptic area, peak during ejaculation, and fall during the post-ejaculation interval. The transmission of glutamate is controlled in the central nervous system by glial cells called astrocytes. Glutamate is incredibly important in the medial preoptic area in regards to ejaculation because astrocytes regulate production and reuptake of glutamate. This study hypothesized that astrocytes will affect the sexual behavior of male rats. This study examined the amount of astrocytes in the medial preoptic area and if their amount played a role in ejaculation latency and the duration of the post-ejaculation interval. 30 female rats were surgically made infertile to participate in this study. Then, 30 male rats were divided into two groups of 15. The sexually experienced group were given 6 90 minutes of sexual encounters with hormonally primed novel females in their home cage. At each time, there was a maximum of 8 males at each sexual encounter, and there were 2 per day. They occurred in a dark room, complete with 1 red light for videography. 4 to 7 days after the last sexual encounter, males were given a sexual behavior test. The following behaviors were scored: mount, intromissions, latency to ejaculate from first mount, and the length of the post-ejaculation interval. Subjects were killed 1 hour after their last ejaculation. The data was determined by utilizing a 2-way ANOVA test and Pearson's correlations. The brains of the subjects were sliced and the astrocytes were analyzed. The results showed that the duration of the post-ejaculation interval showed no variability among the groups. Inexperienced subjects took longer to mount than experienced males, but there were no difference in the number of mounts. The duration of the post-ejaculation interval did not have any discrepancies among the two groups. Pearson's test showed that there is some negative correlation in the amount of astrocytes in the medial preoptic area and duration of ejaculation latency in inexperienced males. But there is no correlation of astrocyte density and ejaculation latency regardless of sexual experience. There's a negative correlation with ejaculation latency and the number of preoptic astrocytes in sexually inexperienced but not experienced animals. Because there was no difference of astrocytes among the two groups, it is possible that the sexual experience can change astrocyte processes, projecting a glutamatergic synapse in the medial preoptic area. Glutamate, which is regulated by astrocytes, plays a role in the initial regulation of sexual behavior, but it is possible as the behavior progresses, glutamatergic projections from the other brain areas like the BNST and the medial amygdala become the dominant modulators. Analyzing this experiment, there are a few things that come to mind that were done incorrectly. Firstly, between the two test groups, there were 13 sexually experienced rats and 11 sexually inexperienced rats. In a perfect execution of an experiment, the test groups would be the same. Also, the researchers admit that they performed an error when they assumed that all astrocytes would express the GFAP protein. This may have underestimated altogether the total amount of astrocytes. The experiment overall followed the scientific method. Therefore, it should be viewed as a success. As Jimmy Neutron would say, kids, got a blast.